Welcome to everyone. So today I am starting the engineering mechanics of the B.Tech course. So that's the fundamental of mechanics. I am starting. This is the chapter. So see, at first we have to know what is this mechanics. So see, mechanics means what? Mechanics is a branch of physics. Here I am writing branch of physics which deals with what? Action of force. Which deals with action of force, whether the body is in rest or in motion. Okay, so this is the branch of physics. Physics means what? This is the branch of applied physics which deals with what? Which deals with action of force, action of forces, whether the body is, this action of forces, whether the body is in rest or in motion. Okay, so this is the mechanics. Now, mechanics can be classified in three categories. Okay, mechanics can be classified into three categories. First one is your mechanics of rigid bodies, mechanics of rigid bodies. Next one is what? Mechanics of deformable bodies, mechanics of deformable bodies, or strength of deformable bodies, or strength of material. This is also the part of mechanics, strength of material. And okay, and third one is your fluid mechanics, okay, or mechanics of fluid, mechanics of fluids. Okay, so this is the three categories. Now, so next one is your what? Mechanics of the rigid bodies. It can be classified into two categories. That is what? That is statics. One is statics and another one is what? Dynamics. Very important. So in case of statics means what? It deals with if the body is at rest, then what is the cause of this rest. Another one is what? Dynamics. Dynamics can be differentiated into two parts. One is your kinetics, and another one is your kinematics. So in the kinematics, what is here? What is the, suppose if any body is in motion. For example, if I consider, just see, if I consider this is the car. Okay, so this is the car. So car is in motion, right? This is the car. So car is moving, right? So moving with some certain velocity. Now, what is the reason? What is the cause of its motion in the kinematics part? We are not considering these things. Okay, that is the force. Force we are not considering in this kinematics part. But in kinematics part, what is the cause of motion? Okay, I mean how much forces are acting, how many forces are acting, etc. on the body. That things we are considering in case of this kinetics part. Okay, so this is the mechanics part that I have told you. Okay, next we are considering, that is what? So okay, next one I am considering, that is what? Some topics of the mechanics. Okay, some topics of the mechanics here I am discussing. So see, first one is what? In case of mechanics, one thing you have to understood, the term is space. Space means what? What do you mean by space? So space is what? Space is actually, this is what? A geometric region. This is a geometric region where you can define the position of the particle. Okay, suppose for example, if I consider that, suppose it is the mosquito, or okay, this is the mosquito is flying. So if you want to define the position of this mosquito at any moment, so you can just see, you can define the position of the mosquito by using the coordinate system. Here I can use the Cartesian coordinate system. So this is your x, this is your y, this is your z. Okay, so mosquitoes is suppose at any instant at P point, so its position is denoted by this one r, and r you can express by which way? By this three-dimensional coordinate system. So from here I can draw a perpendicular, right? This is the perpendicular that I have drawn, and see, this is your x. This, if you draw, this is P point. Suppose I am considering this point is Q point. From Q point I am drawing a perpendicular to this y axis. This is your y, and C, and again if I draw a perpendicular from P to this z axis, this is your z. Okay, so the position of the particle you can define by this x, y, z, right? Suppose, for example, if I consider any particle is moving in like this curved, okay, curved path, right? So this curved path, if any particle is moving, okay, or in the circular path, so in which way you can define its position? Suppose any particle, any object is moving in this circular track, so its position can be denoted by which way? Suppose at any instant the position of the particle is at A, so after t time it reaches at B point. So that is what, which things, I mean, which coordinate you can use here, r, and this is what, angle theta. This is called the polar coordinate. Okay, so r theta is your coordinate. Okay, same way, suppose for example, if I consider an insect is moving in a spherical path, so okay, in a sphere, on the surface of the sphere. So see, this is the, suppose this is the any insect, suppose I am considering this is the ant. Okay, this is moving. So in case of, this is the sphere, okay, and see, this is the center. So here, how you can define its position? You can define its position by using the spherical coordinate. So spherical coordinate is what? This is called r. Okay, now next one is what? Okay, this is called r. This is your theta. Okay, theta, and see, from here, suppose ant is at P point, from here if I draw a perpendicular, then see, now see here, and if I consider this point is the A point, and if I join this O to A, then this is your phi, this angle is your phi. Okay, so how you can denote it by coordinate? So that is r theta phi. Okay, so r theta phi is the coordinate of the spherical surface. Okay, spherical coordinate you can say. So this way, this is what, this is the space. Okay, understood?